Alright guys, welcome back. We're already to Module 2, Lesson 5. So now we're on rotations, what they are and how we use them. So we're going to be able to define and perform rotations. We're going to know that rotations, just like translations and reflections, are going to move lines to lines, rays to rays, segments to segments, and angles to angles. We're going to know that they also preserve length and measure. Okay, that means they are a basic rigid motion. So we have three basic rigid motion transformations. They are translations, reflections, and rotations. Okay, each of those preserve length and the measure of angles. We know that just like translations and just like reflections, if we start out with parallel lines and we rotate to them, we're also going to have parallel lines when we are finished. So all three of these have all those properties that are the same. The difference is just going to be the actual movement. A translation slides, a reflection flips, and a rotation is going to spin. It's our last of our basic rigid transformations. So this one kind of looks like that same thing that we looked at in Lesson 1, which is how would we get from this original figure here up to this new figure, okay? Do you think a translation would work? If I slide this up and to the right, is it going to be exactly like it is here when it ends up here? And I don't think it's going to be. You try that with your transparency if you want to try to recreate that, and it's not going to work. Okay? Well, what if we reflect it? What if I flip it? What if I have this line of reflection that goes here? Could I reflect it over that and it end up here? And then maybe I'll reflect it again over this line. Will it be exactly like this one is? And the answer is no. There's going to be a basic rigid motion, one transformation that is going to get us from this figure to this figure, and that's going to be a rotation. Now, the problem that we have with a rotation that people tend to get confused is they think, well, if I rotate this, I can only rotate it from a point on that figure. And it is true that you have to have a point of rotation, and it's true that most of the time your point of rotation is on figure itself, but that is not always the case. Okay, so we do have to have a point of rotation, but if I rotate it just around this point right here, I can't ever get it up here without using a slide or a translation. But we're only looking to use one transformation. And to do that, to get it from here to here, by only rotating it, we're just going to have to use a point that is off of the figure itself. So if we look and we have our center point of rotation up here, away from the shape, then I can rotate this 90 degrees. You notice the 90-degree angle here. I can rotate this 90 degrees counterclockwise, and it will map this figure to this figure perfectly. I can also go this direction and go 270 degrees counterclockwise, and it's going to get me to that exact same shape as well. Okay, so a rotation. Now, if you notice, it says they are always between negative 360 and 360. Where does that number 360 come into play? Why do you think they would use 360? If you guess because it's a circle, you're absolutely right. What we created when we drew that was a circle, because a circle is what you get when you rotate a figure. The most you can rotate it to get it back would be 360 degrees. Now, the negative tells us the direction. It's not only the degree of rotation, that negative tells us, oh, that means we're going to move it clockwise, which is kind of counterintuitive, but clockwise is if you have a negative degree. So, of course, if it says a positive 360 or a positive 90 degrees or a positive 180 degrees, that means we're going to be moving it counterclockwise. That's a good note to have for you, because most of the time they will tell you clockwise or counterclockwise, but sometimes they'll just give you the sign, negative or positive, and that also tells you the direction to take it. Now, that's if you have one figure to move. You may be asked to move several figures around a center point. Okay? So maybe we're asked to move all of these figures around this center point O. Right? Then I would take my transparency and I would trace each of these shapes and lines and points. And I would take it and I would hold my transparency, I'd lay it on top of it, trace them, and I would keep my finger right here and I would rotate my transparency either left or right. If it doesn't give you a specific direction, it's up to you. And you can move that 90 degrees clockwise, 90 degrees counterclockwise. It's up to you, but you have to hold this point very still. And after I do that, let's say that my line L was now here. So now I have this L prime. And my AB ended up here after I rotated it, and it was A prime, B prime. I just rotate them all the exact same distance, and I trace them all after I rotate it. Okay? And maybe my D prime, C prime ended up here, and my angle ended up here is G prime, notice I have to keep my prime notation, F prime and E prime. So I rotated all of those around point O down here. My point O stayed the same because that's what I kept a hold of with my finger. That's what I needed to make sure didn't move. But none of the angle measures changed. My angle measure is the same. My distance is the same. Everything is the same length of measure because a rotation is a basic rigid motion. Okay. Now, if you go and look at page 19 and 21, you're going to see on page 19 that they want you to rotate this segment OP, and it just says rotate it so that the degree that you're rotating is greater than or equal to 0, and you need to find P prime. So that means you need a positive degree. If it's a positive degree, you need to look at the notes we just took. A positive degree means that I'm going to be moving that counterclockwise. So you are going to draw that figure. There we go. You're going to be drawing that figure, so you have your original, and your new P prime is going to have to be somewhere counterclockwise from where you started. So I want you to go ahead and use that understanding, complete pages 19 and 21. All right, now let's look at those parallel lines that we keep talking about. It says that you can rotate it any direction you want to, whatever degree you want to, it does not matter. So you put your transparency over these lines. This is in your binder, so you can do this with me. And you trace this point O, and you keep your finger right there. You keep your finger pressed on your transparency where point O is so that it doesn't move. And I'm going to rotate these 180 degrees. That means I'm going to take my paper or my transparency, and I'm going to turn it upside down. And then I'm going to have my L2 prime, and I'm going to have my L1 prime. Okay? And what you'll notice after you rotate them is that they are still parallel lines because the distance between them did not change. All we did was rotate them. You still have parallel lines after they have been rotated. Okay? Now, you can also rotate a figure on a grid. It says that once they're rotated 180 degrees, like we just talked about the origin. All that means is that my center point is the origin. So on my transparency, I'm going to lay my transparency over it. I'm going to mark my origin. I'm going to put my finger right there. I'm going to label this point down here, this 2, -4. And I'm going to keep my finger right here in the center. And I'm just going to rotate that transparency so that it is upside down. Where do you notice that your point is going to be? If you look, your point is going to be at -2, +4. That's a 180-degree rotation. Well, what happened? Those numbers look very familiar. This 2, -4, when rotated 180 degrees, became -2, +4. Okay, what happened is that they went from one coordinate, this one quadrant 4 down here, to quadrant 2. It just completely flip-flopped where it was when you go upside down. So when you're doing 180-degree rotations, you can do it even without a transparency because these numbers, this 2, -4, means that the signs are going to be the exact opposite because we are flipping it upside down. We are changing it 180 degrees. Okay? So now, using that same knowledge, try pages 27 and 28. They're 180-degree rotations. Use your transparency or don't. It's up to you. but try to complete 27 and 28 for me now. All right. And now let's look at the lesson closure. So what have we learned today? Let's summarize. We know that we have to have, in order to rotate, we have to have a center and we have to have the degree. Positive degrees move it counterclockwise. Negative degrees move it clockwise. We already took that note earlier in this lesson. We know that it has the properties of a basic rigid motion. It maps lines to lines, rays to rays, segments to segments, and angles to angle. Preserves the length of measures and the length of segments and the measures of angles. Okay, so everything about a rotation is the same as a translation and a reflection. They are all basic rigid motions. The difference is that this rotation is going to spin. Okay, please complete the problems and the pages that have been asked in this, and if you have any questions or comments, I'm excited to hear about them tomorrow. Have a great night.